Question 7 is about the factor theorem. We know a root of this cubic, x equals 2. Let's call this cubic f of x. So what does this mean? Well, if we sub in 2 as x, then that should equal 0, because it is a known root of the cubic. Let's put 2 back into the cubic to get 2 cubed minus 3 lots of 2 plus k equals 0. Now this will help us to find the value of k. So this is 8 minus 6 plus k equals 0. So we can see that k is equal to minus 2. Now that we've found our value of k, we can put this back into the cubic to get x cubed minus 3x minus 2 equals 0. X equals 2 is a root, therefore x minus 2 is a factor of the cubic. Now, we're supposed to find the other roots of this equation. How do we do that? Well, there are many methods that you could use. For example, long division or factorising by inspection. I'm going to use the latter. I definitely know that I'm going to have an x squared as our first term in this bracket. If we multiply this out, then I'll get x cubed minus 2x squared. When factorising the remaining polynomial, I like to keep track of the terms that I've got on the side. So we can see that in the original cubic, there is no x squared term. So I'm going to have to add 2x in this bracket. So I can add on 2x squared minus 4x. So these two cancel. That's good. Now you can see that I've got minus 4x, but I actually need minus 3x. So I'm going to add 1 here and expand this out to get plus x minus 2. So we can see that this is actually equal to x cubed minus 3x minus 2, which are all of these terms here. So that's very good. We can further factorise this quadratic into 2 linear factors. So we get x plus 1 and x plus 1 again. Let's write it in a neater way. X minus 2 multiplied by x plus 1 squared equals 0. So they want the numerical values of the other roots. So we can clearly see that x plus 1 is a repeated factor. Therefore, x equals minus 1 is a repeated root. So we can write this twice. I hope that made sense, and thank you for watching.